Hi all, my name is Vladimir and you are on the Nightly Code channel. First of all, I want to thank Boris who helped me with design of Linux Studio plugins 1.2 for the new logo, which I already published on the channel. And additionally, I would like to thank Anfa for a new Tux image, which you can view on the preview of the stream. As far as you remember, in previous stream we found out how does the mute group or mute button of outputs work in Scarlett devices, and I explained my setup, and now I would like to explain some improvements from the previous stream. First of all, I don't need a laptop more. I just created a new virtual machine with Linux on the board. This is OpenSUSE Leap 15.3, the 64-bit version. I just don't know why it didn't start the GUI session, but this doesn't matter at this time. And as usual, I have a Windows machine, and all should work pretty well. We will just check this by issuing the dmisk -c dmisk -w. We will just connect the device to the virtual machine and see that our driver shows that the device is connected. And as you remember, we have already dumped the kernel, not the kernel, we have dumped this internal state of the software configuration area of the device, and this driver does so. So we see, as usual, that our mutes are set, and we still need to explore how these mutes are shown in the ALSA mixture. We select the device by pressing F6, and seems that we don't see this device. That's nice. And what's about here? Okay. That's interesting. Item master. We don't see the card pulse audio. Anyone? I didn't expect this. Oh, yes. We need to disconnect and connect again. And probably we don't see this. That's strange. I don't know why it didn't show us. Let's try again. Probably I need to reboot the device. I'll try this in this moment. Probably it has something wrong with it. We'll wait a bit for the virtual machine to reboot. And it doesn't reboot. I see. But I can't connect to it. I think I need to force shutdown of the device or the virtual machine and try to launch it again. Yeah, it's loading. It's loading. Okay, the UI has started. Maybe I need to log in. Please wait a moment. Sorry, I had some problems which were required to be solved. Anyway, let's go back, connect to the device again. Oh, yes. tmx-w and connect here. And try to look into also mixer. Oh, that's still no sound card. That's strange. I probably need to log in. Maybe pulse audio or something else. Uh, the device is visible. And what's an also mixture? Oh, yes. That's strange. I don't know why I should log in to see the device. Okay. Here, what we see at the first time, all mutes are disabled. So the mute shows the reverse state of the real mute channel. So we need to fix this. And additionally, we need to implement mutes for SPDIF and the and the loopback outputs. So that's strange that I didn't see the ALSA mixture when I was logged out. If you know what's the reason, please tell me or let me know. Maybe some drivers weren't loaded or something else. Anyway, now we are ready. And the first time we need to review the kernel driver. I renamed my driver to distinguish the current kernel driver from my version of driver. In the previous video, I was a bit lost between the files with the same names, and now that's not a problem. Okay, the next problem is that I have rebooted the machine and the mounted file system was unmounted, so I need to remount the file system. I'll do it at this moment. Okay, it should reload now. I probably need to press F5 or reload the file. And now we see the current kernel driver and my version of driver. So we need to explore the Focusrite Scarlett configuration area and look for the mute switches. There is mute switch with Scarlett 2 analog out max of the array mute switch of Scarlett 2 analog out max size. And in my version driver, my version of driver, the same field is called mutes, just mutes, and it has another size, Scarlett 2 all out max. What's all out max here is 26 outputs. This is true for the Focusrite 18i20 device. And I probably need to change make the first change by putting this value as the size for the array. So here's our mute switch, and I need to replace it. And the second, I probably need to add a comment. Mute switches for each output. I will place it here, including the software switches for non-analog outputs. Okay. Now we need to explore how the driver works with mute switches at this moment. I think I need to find the mute switch in the code and look what's happening there. So here's the Scarlett 2 USB volume status. It's the part of the configuration area of the device, and it starts with a hexadecimal 31 byte offset from the start of the dump. So we probably need to look into the DMESC. I need to reconnect the device to see the state, and just unplug the device and plug it again. Okay, we see the state, and here's the beginning of the configuration area, and this part of the area is what the Scarlett 2 USB volume status reflects. So then what's next? This is not interesting. This is here. Scarlett 2 update volumes. What's this? We need to recall how the ALSA mixture driver works. There are two sides interacting together. The first side, the client software, the mixture software like ALSA mixture, the middleware which connects the device and the mixture software, the driver, and another side, the Focusrite device. When something is changed in the Focusrite device, a software interrupt is delivered from the Focusrite device to the kernel driver, and kernel driver marks some parameters of the device as updated and needed to be reloaded. From the other side, there is a client software which looks for events from the driver, and when some changes occur from the device, the driver notifies the mixture software that some controls have been changed. At this moment, when the mixture software receives the information that some controls have changed, it reads the controls from the driver by specifying by calling special routines and performing special IOCTLs, and the actual information at this moment can be obtained from the device. So if we look back, there are some state flags, and there are also some flags that indicate that these flags have been changed here and need to be updated. I believe that was in the previous version of driver, and is kept for the new version of driver. Okay, we need to look forward. So this routine is used to reread the configuration from the device when the status of monitoring section like volume, dim, mute buttons or something similar has changed. And this routine reads this chunk of memory from the device and applies changes to some controls. So this is the first routine that we should modify while working on the driver. I need to put the bookmark, I think, and walk through. What's next? Here, since the mixture driver provides controls for the parameters of the device, Each control can be changed by calling the get and put methods. So we can provide the methods for specific controls which handle these get and put calls. So actually at this moment, at this place, these methods are provided here. So we need to modify these methods too. So I need to put bookmarks here too. Here's the Scarlett 2 software hardware change. This probably is the routine which is called when we change the software or hardware control between the volume. So probably I don't think that it was in previous version driver, but I think we need to take an attention at this part of code too. So we will add a bookmark here. What's next? Scarlett 2 demute CTL put here. Oh, this we know that muting is very tightly combined with the dim and mute global buttons. What do these buttons do? If we press the mute, all outputs that are marked as hardware controllable also should be muted, and vice versa. If we don't mark the outputs as software controlled, these outputs shouldn't be muted. So we also need to take attention at this routine. What's next? Scarlett 2 read configs. This routine is called at the initialization stage of the driver, and we also need to properly read the state of mutes. Here. So we need to place a bookmark here too. And what's next? That's it. And next. Oh, that's all. I didn't see where the mute control has been created. We need to find it. I think probably it should be here at line out controls. And the mute, as we previously reviewed, is provided, the mute creation is provided here. So we need to bookmark this too. So the first of all, we need to create additional mutes that are related to the non-hardware controlled mutes or non-analog outputs. So we need to check which outputs we still have. We have analog outputs, which we should skip. We have SPDIF outputs, we have ADAT outputs, we have mix outputs, we have PCM outputs, and we have count the overall number of these enumeration constants. By another side, we should look into the into my notes, which I did when reversing the driver, and not this. Probably this, yes. And we need to look into the mute settings again. Here's our notes, which we have written the previous stream. And we need to see that for the 18i20 device, the mapping of bits is a bit different. And for 18i8, it is a bit different too. So we need to define some way how to set these bits independently on the device we work. According to my understanding, we need to define the mute mapping structure. So we probably uh, will define it at the start of the file. So we just need to find the right place. So that should be somewhere near to Scarlett 2 device info. Probably here. Where are the constants? They are at the top. Okay. I think I need to check where this count is used. Port count. Okay. Port count. Okay. All right. I think we need to not to add new constants here. We just need to set the mapping, the type of the port and the offset of this port in the bits relative to the 0 bit. So probably I don't think that this is the best solution, but I think this is reasonable to do at this moment. So we need to define additional structure. Struct Scarlett 2 output mapping. And what we need here is just the U08, the port type, or we don't need the structure. We can do in the way the way that Geoffrey Bennett did. We can define the mapping here. Port count. I think this should be uint U08 port mapping Scarlett 2 port count and Scarlett 2 port dear numbers. Not dear numbers, directions. So we have input and output directions, and we have a port mapping to the software configuration area. So we need to SW to rename it as SW port mapping and place this somewhere at the end and write the comment that this is the port mapping for software configuration area. I think this port mapping is true for other parameters. So I think this will be very reusable. And for the 18i8 device, I will define the port mapping. This is the Gen 3 device. Here, port mapping. And here we will define offsets. We don't need this. We don't need this. The offset of the SPDIF is 8, as far as I remember. Yes. And there are 2 SPDIFs. We don't know anything. Also, we need to check which are the inputs and which are the outputs. Probably we are working on inputs at this moment. So we need to check that what the direction constant is. Oh yes, port in and port out. So we need to fill zeros here. And place the values here, the outputs. The SPDIF offset is 8. The loopback, we don't know anything about the loopback at this moment. I think we'll add loopback a bit later. So we just need to remove all other constants. Probably I need to I need to set up tabs instead of spaces when indenting text. Tabs, okay. And port mapping. Okay, we don't have any port mapping here, but we have additional port mapping except the SPDIF. But we have port mapping here. We have SPDIF with offset 10. Then we have a DAT with offset 12. So here 10, 12. Then we don't have the and we have also the loop back, and probably I don't like the PCM calling of this. I think we should implement the additional loop back, and this is what we here see. Mix assignments. I don't remember how many PCMs there are. Anyway, I think we can leave the loop back at this moment and just work with the SPDIF and ADAT. I think we will probably return back to loop back when we will ready to work with the loop back. So what do we have at this moment? We have port mapping, and we can introduce additional controls that allow to perform this port mapping. So we can add these controls, add the Scarlett to control. In initialization. So we can add additional channels here by just looping over the port mapping. So what's the structure? Info, okay. I think I will open the driver here and return back to device descriptor. Device info, yes. No, this. Okay, software port mapping. Here, create software controllable mutes. And here, probably we will do the same stuff we did here. But in the for loop. What I also don't like is that there is no description, probably. Or is there a description? Oh, yes. Ports. Playback, capture. And that's all. Where is it used? I think I need to check that. I really don't like the way that I don't really like the way the ports are described here. Capture, playback, SPD for analog. Scarlett to ports. Description of each hardware port type. ID hardware ID for this port type. That's good. Source descriptor. Format string from MUX in input selections. Oh. Mute switch. Switch. Okay, I think we need to add new descriptor here. Const char asterisk const mute descriptor. How does it format the code there? The name of the mute descriptor there. I need probably to return back and check. Add line output seed controls. Line playback volume. Mute playback switch. Okay, I think we can just take this and just put this here. The mute descriptor should be this. And here we can just reuse this constant playback volume. That's strange, since this volume switch control playback in num. I really don't like the way the driver is naming the outputs. Analog output playback. What can we do at this moment? I think I need to check how it was done in my version of driver. Scarlett to button names. There was a constant. Oh no, that's not this. Oh, there was the Scarlett to format port name. And where's the function? Oh, okay. And there should be constants that describe this format string. So here's the char output, length, format, device info, direction, and number. And here's, yes, source description, destination description. And there are ports, and ports, port type, number, direction was info ports, yes. And where are, oh, yes, that was that. Oh, the previous version of the driver used this following format of port naming. It didn't use any playback or some their capture or something else. I think I need to check where's the used dst description. Add mux enums and is that all? Oh, that's all. Oh, it's forming the enum. Oh, that's not flexible. That's really not. And what's the source description? Okay, I think I need to remove this field at this moment and just reuse the destination descriptor. Types. Channel +1. Oh. I think that's not good. Again, that's not flexible and that doesn't allow us to generate the proper name of port. I think that the name of port should consist of the basic name, the number, and the basic name, the number, and the type, the ending. So probably we need to add the port name formatting routine. for that case. The destination string, the length of the destination string, the format. Do we really need the format? I think we need to have a port type, the port number, or not. Hmm. We need to port type, the port number, and the direction. And probably that's all. Yes. So we need to write the function that will format the proper name of the port. So we need to place it somewhere at the top and do this. I think that should be somewhere here at the almost the top. Static char. Oh, Scarlett to format port name char destination int length, the overall length of string, const Scarlett to device info probably, right? Scarlett to device info. The direction int port type int port number, and let's look back. Okay, what should we do at this place? We need to add this shouldn't be used. We need to copy paste the probably the code that was used, or we can do the string copy length. Oh, we need to get the part description. Oh, yeah, also we need to postfix here. Const char const postfix. Okay. Back to the Scarlett driver. I think I need to open one more. One more part, one more page, and find back and then find again where's the descriptor is used. Where's it? Where's it? Here's it, and DST descriptor, destination descriptor. Yes, DST descriptor. Yes, and that's here. And I need to FMT port name, and we need to check again. Yes, That's here. And we need to, first of all, get this data structure. Need to remove the line wrapping. And here we will have an info. Do we need the info? We don't need the info. Oh, no, we need the info. Do we need the info or don't? We need to check that. Oh, we don't need to check. We need just to take the proper descriptor. So probably we need to do this. Port type, port number, and direction. Direction, port type, port number. And we have the direction as an index. Oh, not that. Scarlett to ports, port type. And direction as the condition. Direction. And use the Scarlett to port type in. And set to the SRC descriptor or to DST descriptor. Then we need to format the port number we need also to check the length of the postfix. So we need in postfix length, string length, postfix +1 for the space character. So if we look at the sprint function, it returns the number of characters it has written to the output stream of the output buffer. So return value, the number of characters printed. Yes. So we need to remember the value and add this. So in printed string number print and length minus postfix length. Descriptor and channel +1 port number +1 we have printed the formatted string as PDF output 1 playback, and at the tail we need to place the rest string. I think we can call string copy, starting from the printed character, and place the space character to as printed plus plus space, and then copy as printed postfix, and length is length. I mean postfix length. And here we should also decrement one more. Oh, I think this should be removed and this should be added. -1. And I probably think the main problem is that string copy, and we need to check what it does if the length of the string overflows. So one related and intended use of a string copy is to copy a C string to a fixed length buffer, while ensuring both that the buffer is not overflowed and that the unused bytes in the target buffer are zeroed out. There is no terminating null byte in the first n bytes of source string copy produce an unterminated string in dest. So we need to take an intention that the actual length of the string is 1 byte larger, and we need to don't use the string copy since we know the length of the string. We need to do mem copy. So this moment we have postfix length in bytes. We have printed bytes without length and without the postfix length and without the space. We printed the space and we appended the postfix. Also, I think that postfix, if we need to check that postfix is null. I think we need to add a check that postfix is null and then don't print it. So if postfix null, then we have the first branch, and else we have the second branch. And probably since the first branch is larger, we need to check for not null. And then we can just copy paste, I mean cut and paste. And here we need to just to print length -1, and for safety we need to place the as length -1 0 character. So the problem is that C requires to define variables at the top, so we need to declare int postfix length here, print it here and disable the postfix length and print it here. So we have so the device info, we actually don't need this. And finally we got this. Oh, we need the device info if we want to use the port renaming. I think that's not important at this moment. I think we can extend this method later. So at this moment that's enough, and probably we need to check how does it work with the mute controls. Add line out controls, and I probably need to call the format port name here and check what's happening. Scarlett 2 format port name, S, size of S, then direction. This is port out. I think I can route the line here. Then we have a port number, direction, port type. This is analog port type. Where's the constant? Oh, yes, this is port type analog. And also we need to add number and postfix. Number is I and postfix is switch. Okay. And do so in such way. I think we can compile the code and check that our function is properly working. So we need to connect to the device, switch to root, change to this folder, and call the make. Probably there will be some errors, or maybe not. Also, we need to disconnect the device at this moment. I think I can cancel the compilation and add additional debug output to the driver. So I need to just write them info message USB audio info mixture chip mixture. Yes, and write the edit mute switch for output number this called this, and place this. I think I probably should add this here. Mute switch name for output. This should be the I for analog output. This should be I and the string S. I is probably int, right? Yes. So we will just print in the driver which analog output name we have generated for this. I think I need to reformat the code a bit in such a manner. Okay. I think now we can compile the kernel code, kernel driver, and install the new version of driver and check how did it work. So I can just print it dmesc-w here. And we need to wait a bit. What's the htop showing? Htop is showing some CPU load, mostly by OBS. And here we are waiting for the compiler and linker. I think I need to take a cup of tea while waiting for this. The virtual machine is doing something, but that's pretty long. I think I need to check what's happening in the virtual machine. There's a make called. That does something. Which tab? Oh, we don't have each tab, so we can install it. Zipper in each tab. Yes. Yes. Oh, there are many errors. U08. Probably I didn't specify the proper name of type. I think I need to look how the bytes are defined in the right way. U8, not U08, U8, just U8. So I need to update the info structure and just specify the U8. What's next? Postfix. That's a mistyped name of variable. So we'll just fix this. Postfix. 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 Postfix length and so on. The mem copy wasn't closed. There's an error too. I think we don't need curly braces here. What's next? S and print S port mapping. Yes, SW port mapping. That's two. That is required to correct. That should be corrected too. Yes. Port mapping. SW port mapping. Software port mapping, and here software port mapping. So I think Scarlett 2 port type out. Probably that's wrong too. I think we need to check again. No, port type count. I think port direction. Scarlett 2 port in, not type, just in. Yes. Port type out. Scarlett port out, just out. And format, I think that's the same there. Port in, right? So probably we need to launch the make again, and it will do the job faster now. What will the each tab show us? It shows that the CPU is not very high loaded. It's about 25% load of the CPU. Now it's 82, but not so much. There are still make working. This long part of the compilation. If you know how to compile the driver faster, please let me know. I don't like to call. Oh, there's an error. S and print S. Oh, yes, the compiler doesn't know anything about S because the actual name of the variable is out. So we need to place out here, place out here, place out here, place out here, and place out here. So that was the additional error, and we need to compile the code again. Now that's the last error, and we will get our driver compiled. I think the next time I need to try to use something like IDE for the code editing. Probably will be that will be more useful, since that allows to me to get some hints from the IDE to complete the typing without an error. So probably this will be useful, but I need to try it a bit later. Now we're waiting until the driver gets compiled. At this moment, we can unload the current USB driver. We need to RM mode SND USB audio and copy the new version of kernel driver, and then connect the device and mod probe this mod. Oh, that's an additional error. No return statement. Oh, yes. The compiler tells us that we don't return anything from the function, but we specify that the function returns the pointer to that character string. So we need to add just return out. I don't think that multi-threading will help this, since but I think we can try. We don't compile many files at this moment. We just do the compilation of a single unit and the linking of this single unit, and probably this won't improve, but I can try this at this moment. I will just specify the 8 cores for the compilation. So and also we can we won't use this. We could use this function inline, but that will blow up the code and make it less understandable. So that's not right. I've misclicked. So we can just make J8 and try how it will compile this time. Yes, that's faster. Thanks. Yes, now we have the linking of the sound USB audio module, and now we can copy it. Thanks, power user, for the hint. We use 8 cores or 8 threads to perform the build. Still, the linker works slowly, and we need to wait a bit. I think that the module was already built. We can copy it or check. We need to change the directory to this. Copy and change dir and do start sound USB USB SND USB audio KO. The time is 21 minutes, and that's probably right. Yes. Oh, that's now the driver was the driver module was created. So we need to wait until it becomes created at the end of the build. So now we can copy the driver and mod probe this and do cp this to lib modulus linux modulus. Oh, that's just version 15.12 custom rt modulus. No, what's there? I think kernel. Yes, sound USB and SND USB audio KO. Now we have copied the new version of driver and we can mod probe it. I will make the multiple command. So mod probe SND USB audio. This. So now we can connect our device and watch for the lock of the kernel. So here's our virtual machine and just do the connection. This device. Okay. Analog output 01 playback switch, analog output 02 playback switch, and so on until the 8. I think that's correct and that's good. So we have added a function that allows us to format the correct name. The only thing I think we need to update is to pass the switch as an argument to the call. Oh, we do this already. Yes. Okay, that's good. So now we can format the software controlled mute, and we can format the software control mute and add this. The only thing I think the problem is that yes, the power user writes that we unfortunately can really only compile separate files on different threads. So we can get the largest speed boost if the project has lots of files. but it gave the speed boost while looking for make files and checking the state of the build. So that boost was good too. So let's go back to our driver and try to add additional switches. We have two ways. We have the first way. We can combine the mute controller for outputs for the whole set of outputs, or implement the new version of control routines that allow to control the audio outputs. I think the second way is more hard, and we can keep the first idea. We can combine the control of physical of the physical outputs and the logical outputs into one function or into one function set. The main problem is that we need to properly number these outputs, and the second problem is that we need to properly convert the number from the index of the output to the right output that we want to configure or we don't need. Let's look into my version of the driver and look how it was implemented there. So I need to get mute. Get line. How was this function named? Called mute ctl get here. Mute control get. What's happening there? We have just an array, and that's not interesting here. What we do related to the put. If we have the number below the number of vanilla counts, we do the first branch. Otherwise, we just set the bit and just commit the software configuration and update the mux. Okay. All right. When we update the mux, we just need to check whether the bit is set or not. And we know about the type of the part. They know about the direction of the output. This is output port or the input port. And probably there is no problem to update the mux, the internal router or the device. So in our case, we probably just need to add additional mutes with new index. Index is taken from the control, and just do the right thing. So here we need a number which will indicate the number of output or the index of the output. So in our case, we need to int mute number using the mute number. Here we need to assign the mute number to 0. And here we need to add the mute number. And here we probably need to increment the mute number. Okay, when finishing this cycle or this loop, we get the mute number exact the same to the number of line outputs. We can just remove this and just initialize the mute number. Here keep the I, and just initialize the mute number with num line out, and keep work with port mapping related to the output. So we need to do the loop for I is 0, I less than what's with port mapping. I need to recall what's there. There is probably the type of the port and then the direction. So we need to Scarlett 2 port type count. I less than Scarlett 2 port type count, then plus plus sign. That's right. And then we need to check if there is a mapping for this port. So we need to check into the, I need to remove the line wrapping here. And we need to check the software port mapping. That's my version driver. Yes, software port mapping, yes, port type count and port direction. So we need to info software port mapping, port type I, and direction Scarlett 2 port out. And we need to check whether this value has value larger than 0 or not. Or we can just do the loop around this and just implement additional loop variable j, and just for j equals to 0, assigning 0, j is less than this, and plus plus j. And here we can add additional line output control, which we can do this in this way, in this manner. Mute switches. Okay, there's Scarlett 2 port format name, Scarlett 2 port out, Scarlett port type. Here will be I, and here will be J. Right? Right. This is type, and the J is the number of the port. Yes, IJ. I think for the same way, I think I need to use J as a top loop variable and I as a second loop variable. Then we will be not confused, and the variables will be on the same place. And that's switch. And here USB audio info, mute switch for output type D, number D is the following, and here JIS. And here we add the control. Scarlett 2 mute control. Here is the mute number. That's important. I think we should move the mute number to make the code look in the same. So the mute number will be assigned 0 here, and here we will do the mute number plus plus. And here we will do the mute number plus plus to make the code look in the same way. And if there is an error, we return the error. Okay. So we have added the mute switches, and now we have to protect our function which works with the mutes to not to set values that exceed the boundary. So we need to go to control put function and add the range checking here. Here we'll lock the value, lock the mutex. Here we'll lock the mutex, then get the previous value according to the index that we have used. Then we have the value, and here we do the stuff. Scarlett 2 USB set config. Oh, that's not right, probably. That's not my driver. That's my driver. Yes. We have the debug message that we have entered the function, and here we have the debug message that we have left the function. Yes. And what's happening here? We have the Scarlett to update volumes call. This is important. This function does many additional stuff. Probably. Yes. Scarlett to update volumes probably is there present. Yes. And probably in my version, Scarlett to update volumes is checking that volume is updated inside of the Scarlett to update volumes. So I think this function Scarlett to update volumes should be modified in the same manner for check reentrance. And here's important to reset the flag after the data has been received. So we will do the same way. And add the comment. Yes. All right. So we need to check where the Scarlett to update volumes is called and just remove the check of the volume updated flag. That's not necessary here anymore. Okay, now we have Scarlett to mute CTL put. We have locked the mutex, and we again need to update volumes. That's important, since the relation of the other mutes to the levels and gains is very tight, and if something has changed, we need to update all related stuff. So Scarlett to update volumes should be done in a single transaction. Okay, now old value private mutes, the new value should be once inverted. And here, when we Scarlett to mute control get, we should also invert the result. The behavior of mute, as you remember, is inverted in the alpha mixture. So we need to correct this. And that's the right way to correct, to invert the output. So old value, new value. If old value doesn't differ from the new value, we just return. Then we go to unlock and do nothing. If we need to do something, we write the new value to mute switch, and then we need to check the index. We need to remember the index. Here is our index. What's line out remap? Okay, probably. Well, what's the line out remap function? Line out remap. What does the line out remap? Line out remap. Oh, this. Oh. This does in such way. Uh, Private info. Okay. What do we know? What do we need to do here? We need to color the remap inside the check. So int index, and we need to check it here if index is less than num line out. Then we do the remap. We still need to assign the value. And if we have an index here less than number of line outputs, then they need to remap this index. Else, we just need to implement our logic. What's with the remap line out Scarlett to mute CTL part put. Okay, here we just call the set config. That's right. Oh, what's wrong? Why is it checking for 0? Did the Scarlett to USB set config changed? Return 0, and what's here? return 0. Maybe that's something wrong. What is my Scarlett mute CTL put? Air1 return air. What? Why should it return the 1? Why should it return 1? I don't understand what's the main meaning of this. Why should it return 1? What's the other? 0? Set writable. Put air 1. Maybe that's the number of changes. Okay. Okay, we'll keep the number 1 here. We just need to move this code here. Set mute change to the device. Okay, and in our case, we need to call the software config to write it. Set mute bit for the corresponding output. We convert the software configuration area else if private software config is not null, then we do the stuff. Otherwise, we write the invalid value to the error code. So, what happens here? We read the mute SW field, which is mapped to our area of the mutes. We compute the index as 1 shifted to left to the number. That's not right here, or yes, that's right here. Then we have mutes. The only problem is that when we create the mute, we need to compute the right value of index. So in our case, we computed the invalid index, so we need to mute control line out create. What's that? There's function software controllable, and here's that's the mute number, but that's That's not right. That's not right. We need to read the mute number from the, so we don't need to use mute number here. We need to use I here, and mute number we need to initialize here in the with the using the info. Info as double port mapping. Yes, initials, but use here the number of ports. This is port count, and here mute number plus I, and this is right. So we need to log this index here. So we need mute switch name for output D, output type D, number D, mapped to index D, and the following. And here we need to put the mute number plus I. So I will wrap the line, wrap the variables, and just add the missing expression, this. So now we have the right mapping. So the only thing we need to check that mute number, if mute number if mute number is 0, then we need to skip this cycle. Continue. And now we have the right mapping. And now we have the right mapping. So now back to the mute control put. And here we just need to check again. So was this mutes, the state of all mutes. Then we have an index shifted value. Then we have mutes. If we set the value, we mute the value. If we reset the value, then we remove the bit from the bit mask. Then we write the new value to the software configuration area, commit this software configuration area, and call the Scarlett USB to set mux. As we see, as we have seen previously in the previous stream, the Scarlett USB set mux is called without any condition. So probably we can move this outside this code and do the such stuff. If the previous code has completed successfully, then we call the USB set mux, and if error is 0, is still successful, then we write the 1 to the error. So probably we have reproduced the behavior of the setting of the mute outputs. What do we need to do at this moment? We need to build the driver, check that we don't have any errors in our driver, and Probably, I think we need to load. We need to load the value from the software configuration area as it was done in my version of driver. I think I need to look at the mutes. Or what did we do? Yes. When we have read the software configuration area, we need to initialize the mutes. Add mute controls. And what we do here, we add mute controls and just read the value of the hardware mutes. Hardware mutes. How do we get them? Oh, here it is. Scarlett USB get config. Read hardware state of config mutes. And we did at this moment. I don't like the reading state of the device, or splitting the reading state of the device and the initializing the device. Probably that's not good as it is done in this version of driver. Here are software mutes. We get the mutes. I think I need to copy this. Where's the read? Add line controls, add line input controls, add mux and nums, add mixture controls, add meter controls, and where's read software config, and then read configs. Why I don't like this is that software config and the hardware config are tightly bound one to another, and update input other, update monitor other, update sync, get volume status, and so on. Here the mute, clamp, volume. Where are mutes? Here are mutes. Probably here it should be inverted. Private mute switch. I think I can just initialize it there when creating controls. Outline out controls. And read the value from the software config here. So we have the mute status. U32 software mutes. read these mutes from the software config here, and I think if info, if private software config is present, then we need to do the whole stuff. So that's right. This, then the and the first loop, and the second loop. Here we read the state of mutes from software config. Yes. And here we need to set the proper value to the index. And the index is computed here. So we need to compute the index. Index is here. And the mutes should be the following: index here and index here. And the last is there in index variable present? No. Index. And now probably we're done with this. So we have software mutes. We have the software config. We have the mask for the mutes. We know the number of ports. Check the corresponding port type has mapping. Then we create mutes. Mapped ports. Create software mutes for all mapped parts. And probably that's all. Just initialize the mute with the proper state. Okay, so once we have read and initialized the mute the state of the mute, we can change this by mute control put, and we can read this by mute control get. The only thing left is that we need to properly route this, and we need to disable the routing for this output. So probably we need to look into USB set mux. And check what's happening there. There is a port type, there is port index, there is mux index, and there is destination ID. And so how do we initialize the port type? Get port start number, port type ID plus port index. And mux assignments. I don't like the Mux assignments table, which is provided by the mixer driver. I'll explain why. Because the Mux allows to define just points which specify which input should be connected to which output. There is no restriction. You may change the order of the Mux assignments, and that won't have any meaning. That will just make the device working as it works. I probably need to look into Mux assignments table. How it is initialized in 18i8 Gen 3 device. And here are the Mux assignments. As we can see, there are PCM assignments. Y0. There's inputs and there are outputs. Okay, maybe. Why is PCM 0? 10 PCMs, and here 8 PCMs, and there are also PCMs. I cannot distinguish what's 8 PCMs, 10 PCMs, 2 PCMs, or 20 PCMs. And here 10 PCMs, 8 PCMs, 2 PCMs, 20 PCMs. Oh way. These PCMs are probably the loopbacks, or probably not. Scarlett to Mux assignments. Port type or key, port index, entry start. I need to learn the structure. I need to look at the structure again. Assignments. How the assignments are defined. Port name. Where are the assignments? This is software control, Mux size, device info, port mapping, port names. Oh, that's mine version, the driver. I was lost a bit. And here are Scarlett 2 Mux tables. What's that Scarlett 2 Mux tables? Max Mux entries. Scarlett 2 Mux tables. What's Scarlett 2 Mux tables? 3. Oh, yes. Okay. That's good. Scarlett 2 Max Mux. Scarlett 2 Mux entry. Okay. There's Mux entry structure. Port type, start, and count. So there is a type of port, the start, and count. The start, the first number of port, and the overall number of ports. Okay. I understand now. There is a Mux assignment of the 18i8 device. There is the port starting with 0, and there are 10 ports of PCM type. Then there are from 12 to 4, and there are from 10 to 2. This is loop back. That's loop back. Okay. Oh, that's hard. I mean, why it's hard? Yes, now we can compute the right port index. It's an entry start and the port type ID plus port index, get port start number, port counts, port out, port type, port count. What's the port count? Mux assignment. Oh, I really don't like this way of routing when the ports are split into parts, into chunks, instead of watching at the role of port. There are two roles of port. The first role is that the port is loopback, and the second role is that this port is just PCM. But it's PCM too, so it just needs to be marked as loopback. What I can do here, we need to check that the port is muted and do not route the input port to the output port. So there is destination ID. Destination ID, which is computed as port index, and Scarlett to ports port type ID. And ID what is Scarlett to ports port type? Scarlett to ports. Let's look what's Scarlett to ports. Gain. Oh, no, that's not. Oh, that's this. Port type ID. Oh, ID is the ID of the port inside the mixer, inside the router as the hardware sees it. So that's not real index of the entry. Where's the port number? Mux assignment stable entry count entry plus plus. So we go through each entry. We have port type this. We have start here. So port index is the start. And we have entry count. Yes. Here we can compute the destination index and check it. So in table and index, DST, destination index, and destination index can be computed. DST index can be computed as there are local variables. Does the compiler allow this? So I think we can use this. Int destination index is the sum of the port index plus entry start plus port index plus the G. And And what's then? And if port type is analog, what's port type? If port type is analog, then we do one stuff. Else, if port type, and if we have mapping, if we have port software port mapping, port type port count, Scarlett 2 port out. You have software mapping. Then we need to check this index. By substituting the number. So we just do destination index. We check if destination index is less than software source is less than private info port count. Is there an alias to port count? Oh yes, there's port count here. Is less than port count this port type and direction. Then we can check the software mute. Else if private software config. Oh, we just need to U32 software mutes. Oh, we don't need to do this. We just need to check that flag is set, and that's all. We don't need to work with software config here. We just need to read mutes. I think we can combine this condition by doing this, that our index fits the range, and if the else, no, not else, and if this range matches, we just check if. So here we need to U32 point DSD ID or source ID is shifted by 12 bits left. That's right. Oh, we can just update the DSD ID, yes. So, sorry, source ID. Then, yes, then they do this. If private mute switch DST index Oh, here. Here we need to define additional variable. We cannot combine this. We need to check in DST offset DST index substitute sub this value, and then if DST offset we need to check that DST index is is greater than this and less than that. So we need to int port mapping assign this value, and here we need to check that DST index is greater than or equal to the port mapping. And DST index is less than this port count. This port count, do you have the port count value? Scarlett to get port start number. What's this? Oh, yes. That's pretty hard to understand. Probably we need to look anyway. That's right. Index, yes. And this is Mux index. This is not that. Index, yes. Port count, I direction, get port start number. Oh, that's get the starting port index number for given port type direction. That's not that index. We are working on the right index. So if destination index is greater than port mapping and destination index is less than port count, port type, Scarlett to port out, so we need to define the port count. The port count variable is already present. Just need to int num ports and store this value here. And here the destination index is less than port, not port aim, port mapping, port map index, port software index. I think this, and port was software index plus num ports. That's probably right. And we don't need to subtract something here, and we just need to check that private mute switch dst index. If it is set, then we just set the source ID to 0. That's right. And here, what's about the mute switches? We just need to check that we are not out of the range, and DST index is less than num ports, and we just set the mute switch. If the mute switch if the mute switch has the mute set, we just set the source to 0. And here we need to add the comment, apply mutes to physical outputs, to device outputs. To several device outputs. So I think we need to add the debug output here to ensure that we have something set properly. So we need to probably dump this, dump the information that we have set the mute switch or not. Just write the mute switch, the value of the mute switch. D and the value and dst index and this. This will indicate that we modify the corresponding value, corresponding data in the mix, in the routing information. And here we also need to log this. Routing table of this is the following, and write since we have incremented here, we just need to write I-1 and rec data I-1. We won't affect the original code, and we will do the following here too. And we have to pad this a bit and write the mux update at the top that we are working this with a specified mux. So we need to write here not here. We need to write here updating mux d person d and write table. And here we call the update of the corresponding mux. I think we need to add a comment. And after that, probably we need to try to compile and check that we are working in proper way. And here we need to use hex representation. So we need to write hex and write the prefix that and there are 6 zeros per each record. And we need to repeat this there to work in the same manner. Okay. I think that we are ready at this moment to try to compile the driver. And check for errors. There are errors and software port mapping. Nothing about software port mapping. That's right. 1978. I don't remember. I think there should be, yes, the line numbers. 78. Yes, that's right. Since the actual port mapping is, in fact, the info port mapping. So we need to paste the referencing of the info pointer here. So port mapping, where is it? Port mapping. Oh, yes, here's it. Okay, what's next? Numline out. Yes, we don't know anything about the numline out, and that's right. Since we didn't, we can copy this from the line control, add line out controls, and here is the numline out here, and we can add this in our code, which is here. So we can just do this, and we have info per count. Do we have info here? We don't have info. Mixture private. Where's private? Mixture private data. So mixture private data, private info port count. So we have private. Where is it? Private info port count. This. And what's next? Mutes. What's mutes? Oh, the line to 2350. Let's look. Mutes. Oh, yes. I think we need to define the variable u32 and not just mutes. We just need to set software mutes. 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 I think we also need to log the message here to set mute to and just write index and value and copy this here and here and here we have the hardware behavior. So the index and the software behavior and dump them mutes. Here we need to do this after the remap. Yes. And probably that's all at this moment. And Scarlett 2 port out. Undeclared. What's wrong? Probably I'm wrong. Scarlett 2 port out. What's the problem? The line 3523. 3523. 23. That's not that line already. Anyway, Scarlett 2 port. Oh, Scarlett. All right. I think we need to run the compile again, the compilation again, and check. There are still set of errors. Mute number. What's the mute number? Oh, mute number. I think the main problem is that it just need not declared it as an array variable int mute number. Private mutes. Oh, not mutes. Mute switch. Mute switch, right? Scarlett mixture. Scarlett. Private. Private. Mm. There's an information, device info, and Scarlett data, and that's mute switch. Mute switch. All right. Software mutes LE32 to CPU. Yes, that's right. We have also the problem with printing. I think map. I think we need to search by this string and check where's the string. Mute switch name for our type D, number D, mapped to index D. What's S? Oh yes, we need to swap the index and S. All right. Here the software mute switch name for output is mapped to this. Okay. Oh, does the mute number still pending? What's the mute number undeclared? What's wrong? There is started to port out still. We'll find this and correct. Scarlett. And here mute. Oh, that's a typo. Yes. Mute number. It is declared here, so we don't need to declare it as int here. And now now we can check. Yes, that works. That's good. Okay, at this time it has built very quickly. Probably the virtual machine was required to cache something or so, and now it's working very quickly. So we just need to unload the driver. We need to disconnect the device. To RM mode. SND USB audio. Copy the new driver. And probably we need to mod probe this and check. Oh, we have already mod probe this. We need just to connect the device and check whether all is okay. So let's do this and check what's happening. Wow. Yes. Okay, let's look what's happened. Okay, what do we see here? There's a configuration. There is dump. And there is no software switches created. That's strange. I think we need to debug this a bit, add additional code. I think we need to check whether we have the software configured at this moment. Yes, we have the software config here, and it is already stored. Why didn't we have created the mute? I think we need to add additional login. We need to log the software mute state. Scarlett to port type count port mapping. We need to log the port mapping. And just output the mute number. And oh, I see the problem. The J should be used here, and the J should be used here. And mute number and port count. And I think I need to write it here and port count. And do this. So we use J as an index, and here we use J and the port mapping and mute number. Port count. Okay, then this is okay. If we have no mapping, we just keep this. And then we just software switch name for output and so on. So we need to recompile the driver, disconnect the device, recompile the driver, and reload it. Oh, this conflicting. Oh, yes. Not port count, num ports, and num ports from here. Copy to here. We have the port count dedicated variable. And then we have here number of ports. Where's the port count? Just here. Oh, we don't actually need this. Info, port count, and so we don't need this variable at all. And now we can check. Oh, that's a port count undeclared. Where's the port count? Oh, mid number. Oh, yes. Yes. Not per count. All right. Uh, we have forgotten to replace one more value. It's here. Num ports. And probably that's all. Yes, and now we can just replace the driver and check. Okay, now we replace the driver and launch the device, connect the device to the virtual machine. This. I hope this will work. Okay, what did the get port mapping for type 0? This port mapping for type 1. This port mapping for type 2, 8 per 2. Here, why 0 per 8? Oh, yes. 8 is count and 0 is mapping. Yes. All right. That's good. 8, starting with 8 to index 8 and 9, and no more. So we have only one mapping, and this is mapping is just bound to SPDIF output. Yes. Okay, that's good. And probably we need to look to also mixture and check what's happening. That's not the right path. We need to launch also mixture. Switch the device. Oh, wow. Okay. Line out, line 02, line 02. I like this look of the also mixture more when many controls are visible at the same line. The only thing is that I don't understand why it's so. Mix A in, mix A in, mix B in. Where are mutes? Okay. Let's look for mutes. Demute. Something's wrong. Hmm. I think I need to switch F5 all. Okay. Master hardware speaker switching PCM. This is a routine. Add that. Padding. Volume control. Mix A, mix B, mix C, mix D, mix E, mix F, mix G, mix H, mix I, mix J. So there's mixture input, analog output, yeah, dim and mute. And where are other mutes? The mutes are missing. I think I need to lock the call of the mutectl get and check. I think I need to quit the also mixture and check again. That's strange since we analog output 01 playback switch. And where's this? I think I need to validate line out ctl add. So we just have added this. That's right, and this is not visible. Why? This is volume control, which is added after the mute switches. Mix C, mix D, mix E, mix F, mix G, mix H, mix I, mix J, mixer input. Analog output off. This is the routine. Demute, and where are just mute switches. I need to check again. So, Scarlett 2 add new control. Mixture Scarlett mute control. Private mute controls I. Oh, I believe I understand what's happening. We have an overflow in the array, so we need to quickly fix this. Thanks, this is covered by other configuration, so we need to replace this value. Mute controls, and mute controls should be replaced by all out max. And mute controls There is a mute controls access. That's not significant at this moment. Here we add mute controls, and below we also have mute controls, but we need to use index there. So that's right behavior, and probably we need to recompile the driver and check again. The pointer to each control is stored in the array of pointers, and when we go out, and then when we go out of the array, then we probably have some problems with it. So I think we need to disconnect the device, check again. Okay, we have updated the driver, and yes, and now we can just connect the device again. Yeah, that's something changed. Let's look. Okay, updating mux number 0, mute switch 0, mute switch 1, mute switch 2, mute switch 3, 19, 0. Uh, I think we need to check again what's. There are incorrect indexes for mute switches. We need to check the mute CTL. Mute controls. Set mux function. And here, gain. Port type, Scarlett port analog. Destination index is port index plus J. Port index is entry start. Okay. And we need to check that port mapping is defined. We need to ensure that port software index is defined. So if it's greater than 0, And only in this case we can work with the mute switch. So we will have analog port type, that's okay. You will have another port type. It should have mapping, and its index should match the range of the mapping. So if the mapping starts with 8 and ends with 10, then destination index should be in range. Is it right? Port type, port index. I think we need to look into port again to the table. That's the one thing that makes me confusing. PN3 device. PCM analog. Port index from 0 to 2, from 0 to count 2, from 6 to. Oh, so port index should be within the count range, but it should be mapped. So destination index is computed as the port number plus count plus j. So this port index plus j, this is destination index, and for SPDIF it will be 0 and 1. So here we need to check that destination index is less than number of ports, and that's the more correct check. So we have port mapping, which defines the start of the bit in the bit mask, and if the port mapping, I think port mapping index should be named. This variable should be named port mapping index. And if we have the port mapping index, then we check the port mapping index plus j. Mute switch. And here we need to, do we need to do something? No, we don't need to do, since remapping is already done. Here we need to do just what we did. We need to update the destination index and check this index. And then mute switch. I think the type should be locked. Yes, the port type should be locked. Okay. I think we need to recompile the kernel. Okay, and now reload the driver, disconnect the device and reload the driver. Now module is in use. Wait a bit. Now it's okay. The driver has been reloaded, and now we are ready to connect the device again. Yes, it seems to be reasonable. Type 1 and type 2. Type 1 is analog, type 2 is SPDIF. Mute switch 0, 1, 6, 7, 2, 3, 4, 5, 8, 9. Seems to be correct. Now we need to look into also mixture. Oh, we see that mute switch for the SPDIF is set to 1. Probably that's right. We need to look into also mixture. Scarlett device F5, and where are our mutes? I don't see. I don't see it again. I think there's there can be a problem which is related to the naming of the ports. I think I need to look how the formatting was made previously. I think I have improper naming. But maybe not. There's a string which I just format. Add new control, Scarlett 2 mute control. Maybe something wrong with Scarlett 2 mute control. I think I need to add this. I think I need to add this call here. I lock this call. and log the leaf, log the end of the call. I don't understand why it's missing here. That seems I did something wrong. But what? Oh, we don't need an error parsing here. Since we handle the error here, do we have mutctl get, mutctl put in the log? We don't have them. Scarlett to add line out controls. The controls are added here. Add new control. The name is also present. The name is the following. Analog output 1 playback switch. I think I need to look the previous value of this. Just open the previous version of driver and look how it was there. Sound USB mixture card again to CC and add line out controls, and there is a sprint line so mute playback switch. It was called in such manner, line mute playback switch. Oh, line mute playback switch, and we have just playback switch, mute playback mute switch. I think we can try to add the mute word to the Gen2 driver. Mute switch. And add the mute switch here too. I believe that that's not best way to fix, but probably that will help. Mute switch. And there should be a descriptor below or above. Oh, below. Where's the Scarlett to mute control? description. Yes, here it is. Mono for control boolean mono info. Okay. Hmm. I don't believe that this will help, but also has its strange naming. Probably if I return the name it will be good, but I don't believe. I just need to check again. So let's reload the driver and check again. There's no device. Oh yeah, I see the Scarlett 2 mute ctl get call. That's interesting. I think we need to check the driver. Line out volume control. I think mix A, mix B, mix C, mix D, mix E, mix F, mix G, mix H, mix I, mix J. Yes, that was the strange muting. Analog output playback mute, analog output playback mute, analog output playback mute, and there should be an SPDIF. Yes, SPDIF output playback mute. So let's look how it will act in our kernel and how it will react on our changes. I need to just press something. Does it happen? So I need to check what's happening here again. I just need to press M and check. So what's happening here? We have pressed M and we set the mute 5 to 1. Hardware mute number 5. And we see that the mute number 5 is set to 1. And in the routing, we have set the source as 0. Okay, that looks reasonable. That looks reasonable. Okay. Now we need to reset this value. And what if we reset this value? And nothing happens. Scarlett 2 mute ctl put. I think we need to check the value that is written. old value, value, and here we just add the dump and dump the value that we return. So if we are working the right manner, and here we need to update the log the that the index isn't valid. And write the index and the pointer to software config. One of two is not working properly. We'll find out what's happening. So we call make gain. We disconnect the device. Oh, there's a problem. 2320 line, and probably the problem is that we need to cast to int, or just return this. Yes. Now we will see in the log what's happening in where the values are not right. Anyway, we found the problem why the switches were not visible in the ALSA mixture. Oh, and now we are ready to disconnect the device. It's already disconnected, and reload the driver and connect the device again. Yes. Okay. Oh, all right. What do we see here? We have created the corresponding switches. We have indices from 0 to 7. Why from 0 to 7? Where are 8 and 9? Where are 8 and 9? I think we probably should switch to Scarlett device and look again. Why the index is between 0 and 9, 0, 0 and 7? Where's the 8th and 4th and 9th index? We have created to index 8 and index 9. We need to check the function. We need to check the function again and check that the index is correct. Map to index. Mapped to index 8 and 9. Probably okay. What's with my SPDIF? Index 0. Why 0? I don't understand why 0. And SPDIF2? SPDIF2 is not working at all. But it is calling, but it is not working. Set mute 512 to 1. That's very bad. Why it's so? I need to understand. Set mute 512 to 1. That's incorrect. Now let's look into log. Index. Element control. What's in the previous version of driver? Mute city output. Mute city output. Index. Element control. Okay. Oh, that's right. Index is oh, now I understand what's the problem. I need to move this here. And add additional variable mask. And here initialize mask index with mask. And log the mask here. Mask. And use mask here. And mask here. So the index actually is 9. Yes. But when we call get, we get the index 0. Why? I think we need to log the index here too. So we have logged the index. We have logged the index. And That's all. Scarlett to mute control put. Then the mixture calls get, and it returns the invalid value. And why the index is 0? Maybe I need to check. Oh, that's right. The main problem is that we calling here the remap, and that's not correct in our case. We need to add numline out here. The element control, store the element control here into the index, and then only after we have decided what to do with index, we need to write the value. So here we need to check the index. If index is less than numline input, then index is remap. Else, if private software config is not null. Oh, we just need to remap the index if only if it has the value less than number of line outputs. And then we need to read this value, and then all is probably okay. So mutex lock, read the mixture, mutex lock. Here we do the stuff, update the index, and return the value. Yes, and then all should be okay. Then just we need to recompile the driver, disconnect the device, recompile the driver, and reload it. Okay, now let's reload it and connect the device. All right. Yes, now it's pretty good. We have this index from 0 to not to 9, and we have proper reads. And now we can just work with the proper device, with the proper out mute, but still it doesn't work. Set mute 9 to 1. Do we have updated the software? What about we have updated software config and get return the value 1 again. And what if we do the mute again call? So actually what's happening? Here the alpha mixture reads the value 1, which means that the mute is disabled. Then it calls the put value, old value 0, the new value 1. Old value 0 means that the mute is disabled, and the new value, it means that uh, the mute is enabled. We set the mute 9 to 1, and the software config is E00. We need probably to check E00 is probably not correct. No, it's correct. I need just to launch calc and enter the E00 and binary. So this is the 8th, the 9th. Oh, this is the 7th, the 0, 1, 2, 3, 4, 5, 6, 8, 9. I probably need to check the mask. I think I need to dump the mask value. If we have the index 8, then we should have the mask 100 in hex. If we have 9, then we should have the mask 200 in hex. So the mask should look like this. And this is the correct mask. If the value is set, then we set the bit to mute. Oh, the problem is that we don't store the new value. That's the problem. So we need to just need to store the new value. We just need to store new value here. Oh, probably we don't need to check this. Just do the following manner. The main problem is that we just need to update the value. Yes. And now it's pretty okay. Here we just update the software configuration in software configuration. And all probably happens good at this time. So we just need to recompile the driver, disconnect the device. Oh, this is not working. Oh, I used the C++ style type conversion. That's not good. I just need to convert to int in such manner and return back and compile it again. Oh, I have a warning. Yes, that's right. The main problem is that we are mixing the declaration of variables and the code. The C doesn't allow this, so we need to correct this immediately and do compilation again. Now it's all key, and we need to compile to reload the driver. Yes, we just reload the driver. Connect the device and switch the mixture. Please wait a bit. Yes, now it's looking. And now we need to switch to mixture and try to switch mutes. Palm. Okay, commit software config. That's good. But I don't see the routing. I don't see the change of mux. Why? Did this return some error? So what we have set the mask, yes, the right mask. Commit software config, yes, and we don't see any mux configuration. I don't see any mix configuration. We need to check. We need to check the error. It should call the Scarlett 2 USB set mux, but I don't see the call at this moment in the log. What if we set the playback 8 mute? It calls the set mux. Probably. I think that commit software config returns something except the 0 in the driver. Or maybe I've missed something. Okay, anyway, what does we see that mute switch works? I think we can just disable the SPDIF and trigger the routing update and check the flags. Oh, I don't see the mux call. Set mux call. The set mux call is done only when I reset the value. What 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 is it? Oh, old value 0, new value 0. It seems that it doesn't detect that change. Old value, new value. Oh, I believe the main problem is that we are wrong at update volumes. Um, Mute switch, yes. Mute. What's mute? What? No, that's wrong. The mute state is written properly here. Scarlett 2 update volumes. That's not true. Where's my version? That's not true. Scarlett 2 update volumes. That shouldn't work in such manner. The mutes should be read from mute field. Oh, wait. No. Where's the volumes? This should be written in such manner. No. If so if we have hardware switch set, else we need to update this mute switch as so. And when we update this, we need to just log this. Yes. And log the enter of the function and log the leave of the function. Yes. So now, if we have hardware switch enabled, then we need to control mute with the global mute button. And we have it, we don't have a global control switch around this mute. We need to read this mute from the volume status. Yes. So key. So probably we need to look how it should work now. So I just disconnect the device. And that's something not working again. Then error undeclared. Okay, error. Where's it? 2190. Oh, where's the word error? Oh, error. Yes. Oh, yes. Volume status. Not mute. what's then? What's then? Oh, mute switch. Yes, yes. So then, what's the line? 190. Two 910. No? 2190. Yes. So, mute switch. Key. Still there are problems. I know. 2192. Okay. 192. Yes. Here it is. Okay. Make. The device is already disconnected. All right. Let's reload the driver, read new messages, and connect the device. Okay, we don't see the reading of the mute switches. Oh, okay. F6. So let's do something like this. Mute. Okay. We have updated the mux. No problem. Mute. And mm, I don't understand why the old value is 0. I think I need to check again. So we have the mute in mute disabled, and now we set the mute. In the log, we see that the value old was 0. The new value is 1. Mute control put. We set the mute 5 to 1. Yes? And then we call mute ctl get, and we get the value 0, which is right for the mixture. Now the mixture should change the value from 0 to 1. I think I need to dump the mute value here. I think mute D is D. And put this lock into locked part. So we know the index, we know the value, and we know return value. We know the return value, yes. Here we know the old value, we know the value, and we know the index. And oh, I probably understand what's happening. Here we get the value by index, but the index has a remapping here, and we need to do the remapping here too. So if I think we need to do the following thing. We need to do remapping only here. So if index is less than numline in out, then we update the index. Here we store the new value. Update the mute state. And here we just do the correct stuff to deliver the value to the device. Here we don't need this error, this is not a problem. And then this will behave in the correct way. Yes. We have the index, we convert the index. Then we get the old value, new value. If old value is different, then we just unlock the driver and return. If the value, if this is the same, if the value is different, we update the value in our table and commit it to the device, and then update the mux. Yes. The only question is why we don't update the mux. We still need to check the error. The only question is why we don't update the mux when we are working with the SPDIF output. So anyway, we need to compile the driver and disconnect the device. And as usual, we have errors. Yes. Oh, yes, and we need to dump the index. Yes. Yes, now we're reloading the driver. Yes, we have deregistered and registered the new driver. And now we need to just connect the device and look what's happening. Okay. Okay. And now switch the device and try to do something. Mute. Okay, we see the call of the Scarlett to mux set. The state of mutes is the following. The last mute switch 5 is set to 1. That's correct. And now we unmute this. And we have the call to the mixture, to the router, to the mix set, yes. That's correct too. And now we have no muting. The only problem is that we don't have the right routing here at this moment. Anyway, that's good. Now let's look how the SPDIF will behave. We'll mute this. Error 16. Scarlett 2 commit software config. Error 16. 16. I think I need to review the Scarlett 2 commit software config and look how it was called in the previous version of driver, of my version of driver. Oh, it returns the incorrect value only in negative. The error is the number of transferred bytes. So that's not correct. To check that error is 0. We should check that error is non-negative. Yes, we should check that error is non-negative and then just do the stuff. So we need to update the Scarlett to USB. Oh, mute ctl put and just check that error is good. The error should not be negative, otherwise it's pretty good result of execution. So this should be corrected. All right, that's good. Just reload the driver. We see in the log that the driver has been reloaded, and now we just connect the device and watch. Also, we need to check the persistence of the switches. So at this moment, the value should be software mutes in such state. Okay, let's look. Uh, let's check the mute. And we have the Scarlett 2 mute control get and mux update. Yes, that's good. This we need to watch at the state of mutes, the F00 state. Yes. But I don't see. Oh, probably it will be not locked. Now what do we have? We have the state of the software config read, and now we need to disconnect the device and watch that the driver has properly restored the state. So this, I think we need to add the log, add the message to the log of which value we have read. Add line out controls. And here, oh, we have software mutes state. Yes, locked, already locked. So we should look, yes, software mutes EOO. So after we disconnect the driver and connect it again, we should see that the state should be FOO, right? FOO. So let's disconnect the driver. And connect it again. Yes, the software mutes is in FOO state. If we load the driver, the both SPDs should be muted. Yes, this is also muted, and these are all muted. So we see that the state of the mutes is properly stored. Uh, at this moment, we should invert the state of mutes and look that it is properly restored again. So I will just mute this, mute this, mute this, mute this, mute this, 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 and unmute the last one, and unmute the SPDIF1 and SPDIF. And why SPDIF2 is not unmuted? So I'll mute this. I'll mute this SPDIF and look forward what will change. So we need to wait a bit until the data will be committed to the device. And again, we need to disconnect the device. And connect it again. Software mutes in EOO state. But I see that SPDIFs are reset. It seems that we are probably improperly initializing the values here. What's the index? What's the index? Oh, yes. That's the problem. Thanks. The memory wasn't violated. And now we can rebuild the driver and check the state again and validate the persistence. So we first compute the index and then use it to check the mask. Yes. So now it's the correct behavior. Okay, let's reload the driver. And now let's check the work of the persistence of the driver. So we have EOO, so one SPDIF should be enabled and one should be disabled. The second one should be disabled and the first one should be enabled. So now we will just invert the state of SPDIF and revert the state of all others. So all mutes should be muted at this moment. SPDIF 1 should be muted and SPDIF 2 should be unmuted. And the last one mute should be unmuted. So I just disconnect the device and reconnect it. The following state of mutes should be restored. We don't see the state, probably. Oh, now we see here. 11111 001. Muted, 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 muted. Unmuted, muted. That's very strange. Software mutes DOO. Yes, that's right. So the 8th should be muted and then 9th should be unmuted. But oh, the last is unmuted and the first is mute. Yes, that's right. And here. And now we will again invert the state of all mutes and make one more check. This and this. So let's wait a bit. Now let's disconnect the device and connect it again. All right, that's good. The last one is unmuted, and the previous one is muted. Yes, this is unmuted and this is muted. I was looking at the wrong output. This is what also mixer should see, and this is what we should see. All right. I think we can stop at this moment. We have mutes working, except that fact that these mutes will corrupt the internal routing of the device. Because they rewrite the state of mux, and that's not good. So the next step, we probably need to dig into the how routing information is stored in the Focusrite device and explore how the driver works with the routing. So at this moment, I want to say goodbye to all who are watching me, and we'll continue the next stream working on the driver soon. Goodbye.